Today we'll discuss CMI's 2016 paper, and this paper again has some very interesting problems. And the first question is a puzzle itself. It says, 4 children K, L, M and R are about to run a race. They make some predictions as follows. K says M will win and myself will come second. R says M will come second, L will be third. M says L will be last and R will be second. After the race, it turns out that each person has made exactly one correct and one incorrect prediction. Write the result of the race in the order from first to last. So what we do is we write predictions of each of K, R and M. So we have 4 positions: first, second, third and fourth. Now what are the predictions for K? Now K predicts M will win, so M will come at the first place and K will come at the second place. Now what about R? R says M will come second and L will be third. And finally M says L will be last and R will be second. So we'll start analyzing. Now the condition given is exactly one prediction is correct for each. We'll start with predictions for M. Now if L is correct, then it simply means that R cannot be true. Now if L is correct, then this third is incorrect, then M has to be true. Now if M is true, then this first is incorrect. Now if M is second, then M cannot be first and K cannot be second. So that means for this child M, this prediction L, it cannot be true because it results in a contradiction. So we'll start again. So we'll say, suppose R is true and L is wrong. Now if R is true, then M cannot be in the second position. So that means this L, it must come in the third position. Now again, second position is fixed. So K cannot be in the second position. So that means this M, it should be first. So now we have our result, which is first one, it should be M, then R, and then L, and then K. So the result of the race in the order from first to last will be M, R, L, and K. Now question number 2 is, a country's GDP grew by 7.8% within a period. Let the previous GDP be 100 and let it now be 107.8. Now during the same period, countries per capita GDP increased by 10%. So let us say in the previous period, GDP was 100 and population was 100. So per capita GDP, it was 1, and now per capita GDP, it is increased by 10%. So it is now 1.1. Now first we'll find population in this next period. So it will be 107.8 divided by P1, and this value, it should be 1.1. So population after this specific time period will be 98. So previously population was 100. Now this population is 98. So the total population of the country, it decreased by 2%. So answer to this question is total decrease in the population of the country is 2%. Now question number 3 is, we are told that this number n, which is 110179, is a product of 2 primes, say P and Q. So we can write P into Q as 110179. Now it says number of positive integers less than n that are relatively prime to n is 109480. Number of positive integers which are co-prime with n is given by Euler's totem function, and this is phi n. Now we know that phi mn is phi m into phi n. So for this function n, we can write phi n as phi p into phi q, and this value, it will be equal to 109480. Now if p is a prime number, then what is the number of numbers which are relatively prime to p? So there will be p minus 1. So that means this phi p is nothing but p minus 1 and phi q is nothing but q minus 1. So p minus 1 into q minus 1 will be 109480. So we can write this as pq minus p plus q plus 1 and it will be 109480. Now we are already given the value of P into Q. So P into Q is 110179. So P plus Q will be 110179 plus 1 minus 109480, which is nothing but 700. Now P plus Q is 700 and P into Q is 110179. We can write P minus Q square as P plus Q whole square minus 4PQ. So there will be 490000 and then minus 4 into 110179. It comes out to be 49284 and 49284 is 222 square. So the value of P minus Q will be plus or minus 222. Now we can either take plus sign or we can take minus sign. So we'll take plus sign, we'll get P as 461 and Q as 239, and if we'll take minus sign, then we'll get P as 239 and Q as 461. So the values of P and Q are 461 and 239. Now question number 4 is, a step starting at a point P in the XY plane consists of moving by 1 unit from P in any one of the 3 directions. So from P, we can move either 1 unit to the right or 1 unit in the direction of angle 120 degrees or in the direction of minus 120 degrees. All these distances, they are 1 unit and each of this angle is 120 degrees. So we can think of this question in terms of complex numbers. This direction, it represents this root 1. This direction, it corresponds to root omega, and this direction, it corresponds to root omega square. Now omega is e to the power iota 2 pi by 3. Omega square is e to the power minus iota 2 pi by 3. So if we are at this point P, then either we can go 1 unit to the right, or we can take 1 unit at an angle 120 degrees, or we can take 1 unit at an angle minus 120 degrees. Now if particle is at 1, 0, it will either go to the right, say a number of times, it'll go 1 unit in the direction omega, say b times, and it'll go say c units in the direction of omega square. Then the final position will be a plus b omega plus c omega square, and we want this final position to be at 2, 0. So that means from 1, 0, we have ended up at 2, 0. There is a net displacement of only 1 unit. So number of such paths is given by this complex number equation, which is a plus b omega plus c omega square equals 1. Now we know that omega is minus 1 plus root 3 iota upon 2, and omega square is minus 1 minus root 3 iota upon 2, and it is equal to 1. If we'll compare its real part, we'll get a minus b plus c by 2, and this value it should be 1. And we'll compare its imaginary part, then we'll get b equals c. So b is equal to c, and if b is equal to c, then a minus b is equal to 1. So the condition that we are getting is the relationship between a, b, c should be a minus 1 must be equal to b, and it must be equal to c. We need to find number of paths starting from 1 ending at 2 such that it consists of exactly 6 steps. So now if it has 6 steps, then it simply means the value of a plus b plus c, it should be 6. Now b is a minus 1 and c is a minus 1. So we can write 3a minus 2 equals 6. Now a, b, c, they cannot be fractions. So that means there is no path which has exactly 6 steps. So number of such paths will be 0. Now what about the second case? Now in the second case, number of steps is exactly 7. So that means value of a plus b plus c, it is 7. Now again we'll put the value of b and c. So it will be 3a minus 2 equals 7. That is value of a is 3. And if the value of a is 3, value of b is 2, and value of c is 2. So now we have 3 steps to the right, 2 steps in the direction of omega, and 2 steps in the direction of c. Now total number of ways in which we can arrange these 7 steps. So they can be ordered in factorial 7 divided by factorial 3, factorial 2, and factorial 2 ways, and there'll be 7654 upon 4. So it should be 210 ways. So there'll be 0 paths in exactly 6 steps, and there'll be 210 paths in exactly 7 steps. Now question number 5 is, we need to find the value of following sum of 100 terms. So let this sum be S, and let this be cos square pi upon 101 plus cos square 2 pi upon 101, and this series it continues up to cos square 100 pi upon 101. Now let us take another series which consists of sine of these angles. So let S1 be sine square pi upon 101 plus sine square 2 pi upon 101 and plus sine square 100 pi upon 101. Now if we'll add them, we'll get S plus S1 as, now cos square theta plus sine square theta will be 1. So 1 plus 1 plus 1, 100 times. So we'll get this first result as S plus S1, and this is equal to 100. Now if we'll subtract second from first, we'll get S minus S1 as, now cos square theta minus sine square theta is cos 2 theta. So it'll be cos 2 pi upon 101 plus cos 4 pi upon 101, and it goes all the way up to cos 200 pi upon 101. We can write this series as summation of real part of e to the power iota 2 pi r by 101, where the value of r varies from 1 to 100. Now, when we look at this term, which is e to the power iota 2 pi r by 101, it is nothing but it is 101th root of unity. Now we know that summation e to the power iota 2 pi r by 101, where r varies from 0 to 100, it is 0. Now we'll take its real part, we'll get 1 plus summation real part of e to the power iota 2 pi r upon 101, where r varies from 1 to 100, it will be equal to 0. So the value of this summation, it is nothing but minus 1. So from here we can say the value of S minus S1 is minus 1. Now if we'll add them, we'll get S as 99 by 2, and if we'll subtract them, we'll get S1 as 101 by 2. So sum of this series will be simply 99 divided by 2. Now question number 6 is, the function is defined by the formula fx equals x square plus 1 when x is irrational and 10x when x is rational. Now at how many values of x in the interval 0 to 4 pi, f is continuous. Now if we'll take any point, then in the neighborhood of any point, there will be infinite rationals and infinite irrationals. So that means this function will be discontinuous at all the points except for the points where the value at irrational is same as value of rational. So this function will be continuous at points where x square plus 1 is equal to 10x. So all we need to do is we need to find number of solution of this equation in the interval 0 to 4 pi. So we'll draw the graphs. So this is pi, 2 pi, 3 pi and 4 pi, and we'll draw the graph of y equals x square plus 1. So these two graphs, they intersect at 4 points. So number of points or number of values of x in the interval 0 to 4 pi where this function fx is continuous is simply 4. Now question number 7 is, you want to construct a non-empty and proper subset S of the set of non-negative integers, and this set, it must have the following properties: that if m belongs to S and n belongs to S, then m plus n belongs to S, and also if m belongs to S and m plus n belongs to S, then n belongs to S. Now the first question is 0 must be in S. Now let us consider some element m which is in S. Now m, it belongs to S. Now we can say m plus 0, which is m. Again m plus 0 belongs to S. Now if m belongs to S and m plus n belongs to S, then n belongs to S. From here we can say 0, it must also belong to S. So that means 0 it must be included in the set. So statement 1, it must be true. Now what about statement 2? 1 cannot be in S. Now if 0 is in S and 1 is in S, then every combination 0 plus 1, 1 plus 1, 1 plus 2, all these numbers, they'll be included in the set. In that case, this set, it will be a set of non-negative integers. It won't be a proper subset of S. So that means if 1 is included, it cannot be proper subset. So there is a contradiction. The statement 2, it must also be true that 1 cannot be in S. Now this third statement is there are only finitely many ways to construct such a subset S. Now if this set S has two elements M and N and they are in set S, then M and N, they cannot be co-prime. That is GCD of M and N, it cannot be 1. Because if GCD is 1, then from division algorithm, we can say that 1 will be included in this set. And we know that 1 cannot be in this set. So it simply means all these numbers M, N, they cannot be co-prime. If the numbers are not co-prime, then for any number N, we can construct a set which is 0, N, 2N, 3N, and it goes all the way up to infinite. This set, it satisfies both the properties. So there'll be infinitely many ways to construct such a subset. That means statement 3 is incorrect. So it is false. Now what about statement 4? It says there is such a subset S that contains both 2015 to the power 2016 and 2016 to the power 2015. So we have 2015 into 2015, 2016 times, and then we have 2016, 2016, 2016, 2015 times. Now if we look at 2015, we can write this as 5 into 13 into 31, and if we'll take 2016, it will be 63 into 2 to the power 5. GCD of both the numbers is 1, and if GCD of both the numbers is 1, then it cannot be included in any subset. So that means statement 4 is also false. So answer to this question will be true, true, false and false. Now question number 8 is a function g satisfies the property such that gk is equal to 3k plus 5 for each of the 15 integral values of k in 1 to 15. Now the first question is if gx is a linear polynomial, then gx equals 3x plus 5. Now we clearly know that if gx is linear, then gx has to be ax plus b. Now there are two unknowns. If we'll put 1 and 2 and we'll compare with this given value, then from here we'll get value of a as 3 and value of b as 5. So clearly if gx is a linear polynomial, then gx has to be of the form 3x plus 5. That means statement 1, it must be true. Now statement 2 is gx cannot be a polynomial of degree 10. Now one way of defining this function gx can be some function qx into x minus 1, x minus 2, x minus 15 plus 3x plus 5. Now at each of the integral values between 1 and 15, this portion will be 0. Then we'll end up getting this 3k plus 5. So it is possible to have a polynomial of higher degree such that for each of the gk, it is 3k plus 5. But in that case, for this polynomial, its degree must be greater than or equal to 15. So g cannot be a polynomial of degree 10. So that means statement 2 is also true. What about statement 3, which is g cannot be a polynomial of degree 20? We can choose this qx as a polynomial of degree 5. So gx can have a polynomial of degree 20. So that means statement 3 is incorrect. So this is false. Now the fourth one is if g is differentiable, then g must be a polynomial function. It is not necessarily true. We can take this function qx as some exponential function. In that case also, it satisfies this given condition and it is not a polynomial function. So that means option 4 is also not necessarily true. So answer to this question is true, true, false, false.
Now in question number 9, we are given a continuous function f and then we have defined two sets. Set T, which is set of slopes of all possible tangents to the graph of f, and then there is this set S, which is set of slopes of all possible secants, that is line joining 2 points on the graph of f. Now the first one is if f is differentiable, then S is a subset of T. So if we take any secant, which is say fx1 minus fx2 upon x1 minus x2, then from Lagrange's mean value theorem, we can say that there exists at least one point C in the interval x1 and x2 such that slope of tangent at C is equal to secant slope. So for any possible combination of x1 and x2, we always have point where tangent is equal to secant. So that means S is a subset of T. That means statement 1 is correct. So it is true. Now second is, if f is differentiable, then T is a subset of S. Now S must be a subset of T, but then T may not be a subset of S. So this second statement, it may not be necessarily true. So this second statement is false. We can take up an example also. Say for example, suppose function fx is sin x. If we find f dash 0 is cos 0 is 1. Now 1 belongs to T. But then if we look at this secant set, then sin x minus sin y upon x minus y, it is always less than 1. So 1 belongs to T, but it doesn't belong to the secant set. So that means the second statement is false. Now this third one is, if T is equal to S is equal to R, then F must be differentiable everywhere. It may not again be necessarily true. We can have a function where tangent set and secant set, they take all real values, but still that function may be a discontinuous function, as in the example of 10x. So again, statement 3 is not correct. So this is false. Now what about fourth one? Suppose it says 0 belongs to S and 1 belongs to S. Then every number between 0 and 1 must also be in S. So at some point, slope is 0, and then at some other point, slope is 1. Now since the function is a continuous function, from mean value property we can say that slope of all possible secants will take all the values between 0 and 1. So that means statement 4 has to be true. So answer to this question is true, false, false and true. Now question number 10 is, you are given a triangle ABC, a point D on the segment AC, E on AB and F on BC. Now it says BD and CE intersect in point P. Now join P with F. Now suppose that these angles, they are all equal and let them be theta. And also PD equals PE equals PF. So PD equals PE equals PF. Then which of the following statements are true? Now first one is AP must bisect angle BAC. Now if we look at these two triangles BPE and BPF. Now this BP is common side. These two angles, they are same. These two sides, they are also equal. So that means these two triangles, they are congruent triangles. And if these triangles are congruent, then BD is angle bisector of B. And similarly, these two triangles, they'll be congruent. So again, this CE will be angle bisector of E. Now we know that angle bisector, they are concurrent. So if P lies on angle bisector, then this AP will be angle bisector of angle A. That means statement 1 is true. Now what about angle BAC? Now we know that this angle is B by 2 and this angle is C by 2. So in this triangle, we can write 2 theta plus B plus C by 2 and this is equal to 180 degrees. Now what about theta? This angle will be 2 theta. So 2 theta and plus 4 theta. So 6 theta is equal to 360. So value of theta should be 60 degrees. So from here we can say value of B plus C by 2, it will be 60. Value of B plus C is 120. So if B plus C is 120, then angle A, it must be 60 degrees. So that means option number 4, it must also be true. Now statement 2 is triangle ABC must be isosceles and APF must be collinear. This may not be necessarily true. If we take any triangle with angle A as 60 degrees and if we consider angle bisectors of B and C, then all these conditions, they'll be true, but triangle
it need not be an isosceles, and these points APF, they need not be collinear. So that means in general cases, these two statements, they may not be true. So answer to this question will be true, false, false, true. Now we'll come to the section B, and the first question is, out of 14 students taking test, 5 are well prepared, 6 are adequately prepared, and 3 are poorly prepared. So we have 3 set of students. So suppose event W, it has set of well prepared students, A set of adequately prepared, and then P set of poorly prepared students. The probability of choosing a student from the set of well prepared will be simply 5 by 14. Adequately prepared will be 6 by 14, and poorly prepared will be 3 by 14. Now there are 10 questions on the test paper. A well prepared student can answer 9 questions correctly. An adequately prepared student can answer 6, and a poorly prepared student can answer only 3 questions correctly. Now for each probability below, write down your final answer as a rational number in lowest form. If a random student is asked 2 distinct random chosen questions from the test, what is the probability that student will answer both questions correctly? Let us say event C is student answers the question correctly. Now if the student is well prepared, then the answers will be correct with the probability 9C2 upon 10C2. Now if the student is adequately prepared, then the probability of getting 2 questions correct is 6C2 upon 10C2, and if it is poorly prepared, then the probability of getting 2 correct is 3C2 upon 10C2. Now we need to find the probability that a student will answer both questions correctly. So it is conditional probability question. The probability that student will answer a question correctly is when we multiply each of these corresponding probabilities. So it will be 5 by 14 into 9C2 upon 10C2 plus 6 by 14 into 6C2 upon 10C2 plus 3 by 14 into 3C2 upon 10C2, which is 31 by 70. Now part B is, suppose the student was chosen at random and asked 2 selected questions from the exam and did answer both questions correctly. Find the probability that chosen student was well prepared. Now this is Bayes theorem question. So if the student is well prepared, then we'll take this case in the numerator. If the questions are answered correctly, then the student is well prepared. It will be 5 by 14 into 9C2 upon 10C2 upon 31 by 70. So it will be 20 by 31. Now question number 2 is, by definition, a region inside a parabola is a set of points A, B such that B is greater than or equal to A square. We are interested in those circles, all of whose points are in the region. A bubble at a point on the graph of y equals x square is the largest such circle that contains P. Now you may assume the fact that there is a unique such circle at any given point on parabola. So we have this parabola y equals x square. And then at any point P, we have to draw the largest circle. Bubble is the largest such circle that contains P. So any largest circle which contains P, it must be tangent to this parabola. And it'll also touch corresponding point on the left hand side also. So let this point P be h comma h square. Now this P dash will be minus h comma h square. Now this circle, it touches this parabola at this point P. Now since this circle, it touches this parabola, that means they should have a common normal, and any normal to circle, it passes through center of the circle. And from symmetry, we can say that center of this circle will lie on y-axis. So let the center be 0, k. Now we drop this perpendicular, then this length, this is h, and this point is 0, h square. So let the center be C and let this point be Q. Now the first part is, if the radius is 1, find the center of this bubble. First what we'll do is we'll find relationship between h and k. We'll find slope of normal to this parabola. So if we'll differentiate, we'll get dy by dx and it'll be simply 2x. Then slope of normal at point P, it will be minus 1 upon 2h, and slope of normal it must be equal to slope of this line, which is h square minus k upon h. Now we'll cancel this h with h. We'll get k equals h square plus 1 by 2. Now it is given that radius of this circle is 1. If the radius is 1 and if we use Pythagoras theorem, then we can write this length, which is k minus h square whole square plus h square, and this is equal to 1. Now what is k minus h square? K minus h square is 1 by 2. So it will be 1 by 4 plus h square is equal to 1. So value of h is plus or minus root 3 by 2. Now if the value of h is 3 by 2, then we can find k. So value of k will be 3 by 4 plus 1 by 2, and there will be simply 5 by 4. So center of this circle will be at 0, 5 by 4. And that's your first part. Now what about its second part? Find the radius of the smallest possible bubble at some point on the parabola. Now from this normal condition, we have already worked out k minus h square is 1 by 2. So this distance between C and Q, this is fixed and this value is 1 by 2. So we can write r square as 1 by 4 plus h square. So that means this r square is always greater than or equal to 1 by 4. So the minimum value of r will be 1 by 2. And we'll get this value minimum when the value of h is 0. So smallest bubble, it will be at origin and its radius will be 1 by 2 units. Now question number 3 is, consider the function fx as x to the power cos x plus sin x defined for x greater than or equal to 0. Then we need to prove that this integral from 0 to 1 fx dx, it lies between 0.4 and 0.5. Now we know that when x belongs to 0 to 1, then the value of sin x plus cos x, it lies between 1 and root 2. Now if we'll take it to the power of x, then we can write x to the power 1 should be greater than x to the power sin x plus cos x, and it should be greater than x to the power root 2, because x lies between 0 and 1. So as the power increases, the value of x to the power y decreases. Now we'll take integral from 0 to 1, then we can write integral from 0 to 1 x dx, it is always greater than or equal to this integral from 0 to 1 x to the power sin x plus cos x dx, and it will be greater than this integral from 0 to 1 x to the power root 2 into dx. Now this is x square by 2 from 0 to 1. This is this integral I, and this is x to the power root 2 plus 1 upon root 2 plus 1 from 0 to 1. Now this is 1 by 2, and it is greater than or equal to I, and it is greater than or equal to 1 upon root 2 plus 1. So we can write this as root 2 minus 1 is less than or equal to I, is less than or equal to 0.5. Now root 2 is 1.414. So that means this value of I, it should be greater than or equal to 0.4, and it should be less than or equal to 0.5, and that's your first part. Now we'll come to the second part. Second part is, suppose the graph of f is being traced in the computer screen with a uniform speed of 1 centimeter per second. Then show that at the moment the point corresponds to x equals 1 is being drawn, then x coordinate is increasing at a rate of 1 upon under root 2 plus sine 2. So we need to find dx upon dt when the value of x is 1. When the value of x is 1, value of f is also 1. Now we know that length of the curve is given by this integral from 0 to x under root of 1 plus then dy by dx whole square. Now in this case, we'll choose some other variable. Let us say f dash u square into du. Now we'll differentiate this L with respect to x. We'll write dl upon dx as under root of 1 plus f dash x whole square. Now we can write this as dl upon dt upon dx upon dt, and it will be equal to 1 plus f dash x whole square. Now we can write dx upon dt as dl upon dt upon under root of 1 plus f dash x whole square. Now we need to find dx upon dt when the value of x is 1. So when the value of x is 1, dl upon dt, it is given that it is 1, and then it will be 1 plus f dash 1 whole square. So now we need to find the value of f dash 1. So for this function, we'll take log both sides. We'll write log fx as cos x plus sin x into log x. Now if we differentiate, we'll get 1 upon fx into f dash x as cos x plus sin x upon x, and then plus log x into minus sin x plus cos x. Now we'll put x as 1. Now we'll put x as 1, we'll get f dash 1 upon f1 will be cos 1 plus sin 1 upon 1, and then plus log 1 is 0, so it will be 0. Now value of f1 is also 1. So from here we can say value of f dash 1 as cos 1 plus sin 1. Now we'll put the value of f dash 1. Then the value of dx upon dt at x equals 1 will be 1 upon under root of 1 plus cos 1 plus sin 1 whole square. So it will be under root of 1 plus, now cos square theta plus sin square theta is 1, and then it will be 2 sin 1 into cos 1. It is 1 upon under root. Now this is 2, and 2 sin theta cos theta is sin 2 theta. So it will be simply sin 2.
Now question number 4 is, let A be a non-empty finite sequence of n distinct integers a1, a2 and an. They are in increasing order, and then we have defined a plus a as ai plus aj for all I and j. So for example, suppose we have the set A as 1 and 4, then all possible sums are 1 plus 1, which is 2, 1 plus 4, 5, and 4 plus 4, 8. Now first part is, we need to show that number of elements in A plus A is greater than or equal to 2n minus 1. Now we have n distinct numbers. We can say that a1 plus a1 is less than a1 plus a2 will be less than a1 plus a3, and will be less than a1 plus an. Now a1 plus an will be less than a2 plus an, which in turn is less than a3 plus an, and will be less than an plus an. So there will be at least these many distinct terms in a plus a. So in this sum, how many terms are there? So from a1 to an, there are n terms, and then from a2 to an, there are n minus 1 terms. So number of elements in a plus a, it must always be greater than or equal to 2n minus 1. So that's our first part. Now what about second part? It says, prove that if number of terms in a plus a is 2n minus 1, then the sequence must be an arithmetic progression. So we'll come to part B. Now consider an AP A1, A2 and AN. Suppose we can write it as A plus D, A plus 2D and A plus N minus 1D. Now if we'll add all the terms, then this set A plus A, it contains elements such as 2A, 2A plus D, 2A plus 2D, and it'll go all the way up to 2A plus 2 N minus 1 into D. Now here in this set, it starts from 0 and it goes all the way up to 2n minus 2. So number of terms in A plus A will be 2n minus 1. So if we take any general AI and AJ, that is A plus I minus 1D plus A plus J minus 1D, so it will be 2A plus I plus J minus 2D, where I and J belongs to 1 to n, it will always lie in this set. So it gives us all the elements present in A plus A. So if A1, A2, AN, they are in AP, then number of terms in A plus A will be 2n minus 1. Now we'll prove its converse. So we'll say that if number of terms in A plus A is 2n minus 1, we'll prove that this sequence A1, A2 and AN is in AP. Now we'll prove this result using induction. We'll prove the result for n equals 3. So suppose we have three numbers A1, A2 and A3. Now number of terms in A plus A will be 5. Now we look at possible combinations of A plus A. It will be 2A1, A1 plus A2, A1 plus A3, A2 plus A3 and 2A3. So these are the 5 possible sums in the case of A plus A. Now what about other sums such as A2 plus A2? Now we know that A2 plus A2 will be greater than A1 plus A2 and will be less than A2 plus A3. Now there cannot be any additional term. So that means this A2 plus A2, it must be equal to A1 plus A3. So from here we can say 2A2, it is equal to A1 plus A3, which shows that A1, A2 and A3, they are in arithmetic progression. Now we'll assume that let Pn be true. That means if number of elements in A plus A is 2n minus 1, where A is the sequence, which is A1, A2 and AN, then A1, A2, AN, they are in AP. Now we need to prove it for Pn plus 1. So we'll take Pn plus 1. Then we'll have A1, A2, AN and we'll add one more element which is AN plus 1. Now from Pn we already know A1, A2, A3 and AN, they are in AP. Now we need to show that this AN plus 1 is another term in arithmetic progression. Now for these n terms, we know that 2n minus 1 term will be 2A1, it is less than A1 plus A2, it is less than A1 plus A3 and it is less than AN plus AN. Now this series, it will have 2n plus 1 minus 1 terms, that is 2n plus 1 terms. That is, by adding an plus 1, we have introduced 2 more terms in the sequence. When we have added an plus 1, there will be many new terms such as an plus 1, 2 an plus 1, an minus 1 plus an plus 1. Now we know that by adding this an plus 1, there is an addition of only 2 terms. So the resulting sequence will have 2 more distinct terms, and which are an plus 1 and 2 an plus 1. So that means this an minus 1 plus an plus 1, it must correspond to some previously defined sum. Now the highest sum is an plus an. So from here we'll get 2an equals an minus 1 plus an plus 1. That is an minus 1, an and an plus 1, they are in AP. So from induction, we can say that if number of terms in any sequence is 2n minus 1, then the resulting sequence must be an AP. Now we'll come to its C part, which is find a sequence A of the form 0, 1, A3 up to A10 such that number of elements in A plus A is 20. Now if we consider an AP from 0 to 8, here the value of n is 9. Number of terms in A plus A, it will be 17. And if we consider an AP from 0 to 9, in that case value of n is 10. And number of elements in A plus A will be 19. So we know that in an AP, when we add one term, it results in 2 additional terms. But in this case, we need this number to be 20 and not 19. So what we'll do is, we'll skip this number 9 and we'll add 10 in place of 9. We'll take 0, 1, 2 up to 8 and then we'll take this number 10. So from 0 to 8, we'll have numbers in a plus a starting from 0, 1, 2 and 16. And when we add 10 to it, then we'll have 17, 18 and then 10 plus 10, which is 20. So we have added 3 more additional terms. So the sequence of the form such that a plus a is 20. It is 0, 1, 2, 3 up to 8 and then 10. Now what if rather than taking 10 we take 11? If we take 11, then 11 plus 6 is 17, 11 plus 7 is 18, 11 plus 8 is 19 and 11 plus 11 is 22. So it will result in addition of 4 more terms, where in this case we just need to add 3 more terms in 17 to make it 20. So it has to be 10. So this resulting sequence is a unique combination of numbers. Now question number 5 is find a polynomial px that simultaneously has both the following properties. When px is divided by x to the power 100, remainder is the constant polynomial 1, and when px is divided by x minus 2 cube, then the remainder is constant polynomial 2. So we can write this px as some qx into x to the power 100 plus 1. Now we'll find p dash x. We can write p dash x as qx into 100 x to the power 99 plus x to the power 100 into q dash x. So we can write p dash x as x to the power 99 100 qx plus x into q dash x. So we can say that x to the power 9 divides p dash x. Now in the same way, when px divided by x minus 2 cube, it leaves the remainder 2. We can write px as x minus 2 cube into some rx plus 2. Now from similar argument, we can say that x minus 2 square, it divides p dash x. So this p dash x has to be of the form some polynomial, say gx into x to the power 99 into x minus 2 square. Now we need to find a polynomial px. So the simplest polynomial can be, we can write this px as sum a into x to the power 99 into x minus 2 square. So p dash x will be a x to the power 99, it will be x square minus 4x plus 4. We can write p dash x as a x to the power 101 minus 4 x to the power 100 plus 4 x to the power 99. Now we can integrate this function to find such a polynomial. So we can write this polynomial px as a, and then it will be x to the power 102 by 102 minus 4 x to the power 101 upon 101 plus 4 x to the power 100 upon 100 plus c. So this could be one such polynomial. Now we are already given this initial condition. When the value of x is 0, value of px is 1, and when the value of x is 2, value of px is 2. So if we'll put x as 0, we'll get c as 2, and if we'll put x as 2, we'll get the value of a. And that is the answer to this question. Question number 6 is find all pairs Pn of positive integers where p is a prime number and p cube minus p is equal to n to the power 7 minus n cube. Now we can factorize this as p into p minus 1, p plus 1, and we can write this as n cube into n square plus 1, n minus 1 and n plus 1. Now this p, it must divide any one of the number on the right hand side. So either p divides n, or p divides n square plus 1, or p divides n minus 1, or p divides n plus 1. Now here we'll show that this p, it must be greater than n square, because if p is n square, then in that case we'll get p cube minus p is n to the power 6 minus n square, and n to the power 6 minus n square is less than n to the power 7 minus n cube when n is greater than 1. So value of p must be greater than n square. So that means the only option possible in this case is this p, it must divide n square plus 1. So from here we can say that this p, it must be equal to n square plus 1. Now we'll put p as n square plus 1. Then we can write n square plus 1 into n square plus 2, and it must be equal to n cube n square plus 1 and n square minus 1. Now n square plus 1 will cancel. N square will also cancel. We can write n square plus 2 equals n cube minus n. We can write n cube minus n square minus n minus 2 equals 0. Now we'll put n as 2. We'll get 8 minus 4 minus 2 minus 2 equals 0. So one of the solution is n equals 2. If we use synthetic division, so this is 1 minus 1 minus 1 minus 2. So this is 0, 1, then 1, 2, this is 1, 2 and 0. So we'll get this as n minus 2 into n square plus n plus 1 equals 0. So the only real value of n possible in this case is 2. So value of n is 2, and if we'll put n as 2, we'll get value of p as 5. So there is only one ordered pair of the form p comma n. So it will be 5 comma 2, and that is the answer to this question.